reason you just wanted to like do something instead. Okay, well let's do calculus physics. How about that? It's not quite physics, but it's mostly calculus. And I promise you nobody will be voted off the island, maybe me, but you guys will get this fine. Okay. You know the slope of a point. Slope of a point is the first derivative, right? Yes? True story? Okay. So we're going to look at the relationship between position, velocity, and acceleration. You guys know velocity is what derivative? Come with the first. Acceleration is the second. What's the third? It's a jerk, because it takes so much math to do. So first derivative, second derivative. You guys have done these. It's no big deal. So we need to talk displacement. When we talk about displacement, this is your original function. Because it's talking about the relationship. So distance is a measure between 2 points. Measurement doesn't indicate direction. Like when you're traveling to Winnipeg, none of the signs saying on your way south say positive 756. On the way back, none of them say negative 756. I might go paint some on there, but that's just me. So distance doesn't indicate direction. Displacement does give direction. Okay, so it's vector based. Got that? Distance, it's like an absolute value. Think of it as the kilometers on the sides. Displacement tells you which direction you're going in. All right. So Kelly travels 750 kilometers from Thompson to Winnipeg. Total distance traveled. I guess round trip. Let's do it round trip. Really? Already, let's do this up. Round trip. So, total distance traveled? I've traveled 1,500 kilometers. What about total displacement? Right? So, because one way would be positive and one way would be negative. I'm not sure if positive is heading south and negative is heading north. I would say it's the opposite. If your compass goes, right, that's the way I would think of it. Heading south would be your negative values. Okay. So now we're going to talk about velocity versus instantaneous velocity. The reason why we're going over all of this is so when we're asked in a question, you guys can actually do it. You guys okay? I don't know who is dying back there. What? If the displacement was real? Oh, I'll do the math. Negative 750 kilometers south plus 750 kilometers north. Add those two things together and I've gone nowhere. If I have a round trip to Thompson, I started in Thompson, I ended in Thompson. What's my displacement? 0. Right? I ended where I started. Okay, velocity versus instantaneous velocity. You guys did this already in derivatives. You guys remember this maybe, possibly? This was the one where you're trying to get your secant lines, that A value, or sorry, the H value, smaller and smaller and smaller. So H is approaching 0. Okay, just pretend. Just pretend. I guarantee you, though, it is in your notes somewhere. Is it really bothering you? You're killing me. Okay, so if I want to find the average velocity, I'm going to take the velocity at the far point. I'm going to subtract the velocity at the point I'm looking for, the F of A, subtract them, and divide by that distance. That's going to be my average velocity. Now, if I'm going to do instantaneous velocity, this is just your limit. This is the one that we've already done. So the velocity that's instantaneous, 30 in there, yes it is the limit formula. So that's going to be the limit as h approaches 0. So we're trying to get those points closer and closer and closer together. So instantaneous velocity is the velocity at a specific point. This is what we've done in calculus. Average velocity, I don't know, you did that in physics, or you did that in grade 10, or you did that sometime, it's not a lot of math. But you did this stuff in calc. You did a bunch of these. All right, so when you find the limit of velocity, you're finding the velocity, the instantaneous velocity. All right, so that I had right there, I'm probably going to combine these notes a little bit. So it says the displacement. So as soon as I see the word displacement, I know that we're talking about f of x. Maybe. F of x. It's moving along a straight line from a fixed point. It's measured in meters and is determined by the position function this. So I know that's my original function, where t has to be greater than or equal to 0. Determine the average velocity for the time interval from t1 to t4. And then determine the time with velocity, instantaneous velocity of 0. Super easy. Super duper easy. All right. So, if we're doing instantaneous velocity, no, we're doing average velocity first. So velocity is the change in what? Okay, the change in distance. In this case, what is it? What letter? Is it S or is it T? Right? Change in S over the change in T. Try and grade T, that's not working. All right, so again, we're in the original function. I need to do some math first, though. It's giving me an interval. If T is 1, what's S? I got 32, I got 34, 35, are we just bidding now? 32, 34, 40, I'd like 32. 31? 31 is the correct answer, FYI. How did we get that? I'm just substituting. It scares me. So 32 minus 2 is 30, plus 1 is 31. Look at that. Okay, so we're just looking for the change in the y value over the change in x value. Have you seen this before? That's your slope, which is the same as velocity. And I need to do T4. This one's going to be harder. Are you sure? Are you positive? I gotta slow down my habits. 4 to the exponent 3 is, are you sure? Right? So we needed to do that little bit of math first. None of that was rocket science. I have faith that you can do all of this. So now we're just going to do the change in S. What's the change in S? Change in S. 64 minus 31. And remember, you got to stack them in order. So it's going to be the change in t. So the t value of the 64 is 4. And the t value that goes with 31 is 1. So I'm going to have 33 divided by 3, 11. I'm going to need some units of measure on that. What's S measured in? Okay, well, we'll assume in a second. I probably should have put that in there. So you're finding a velocity, so would it be meters? I'm finding a velocity, would it be meters? Okay. All right. So let's say you find average velocity, just finding the slope. See, physics is easy. It really is. Okay, what's the deal with instantaneous velocity? What am I doing there? Not okay, so do you want to do the long way or the short way? What? Short way? What would be the short way? Instantaneous velocity is the limit as h approaches 0, f of a plus h minus f of a all over h. You guys remember that? Somehow, maybe. So do you guys know what to do? No, you guys, no, possibly. So this would be where f of a just gets substituted in as the equation. And this one, everywhere you see a t, would have to be t plus h. And then you multiply them and combine them. And that doesn't seem bad until you look at our equation and we have a squared and a cubed in it. So that's going to be really long if I do that. What do we know about this? This was like D2. What happened in D3 when we learned the derivative rules? This got replaced by finding our first derivative. Copy this, hoping somebody remembers. No. So all this is finding the derivative the long way. Velocity is what level of derivative? First derivative. All you have to do is take your equation. So the s of t equals 32 minus 2t squared plus, not 3t, t cubed. And what are you going to do with it? Differentiate to your first level derivative. So s prime of t is equal to negative 4t plus 3t squared. Now, does it tell me instantaneous velocity? You have to go back to the question. It said, tell me the time when instantaneous velocity is 0. So, next step is like a question from your problem set. Find the equation of the horizontal line. When you know what the slope of the horizontal line is 0. So 0 goes in here. That's supposed to be a 0. What would I do with that? I would solve it. I'm sure you're all pretty excited. Well, I'm going to have a common factor first. Cool. A very good job factoring. So I've got t equals 0, and I have t equals positive 4 over 3. So where's instantaneous velocity 0? It occurs at 0 and a second and a third. So at 0 seconds, so it starts at 0, and then 1 second, 0.333 later, it's also going to be at 0. Okay, smokies? Because what kind of graph would you get from this? You get a parabola. How many x-intercepts? 2. Opening up or down? Oh, grade 11. You're opening up. Okay, so you found instantaneous velocity at 0 seconds and at 4/3 seconds. How bad was that? Disgusting. Okay, so you know it's never good when I give you a full page to answer a question. We know that. Pretty straightforward, guys. Do you need more work? No. Oh. Mine doesn't. My microphone's talking to me, if that's what command I want it to say. All right. I don't have any information on that. Okay, so determine the displacement for 0, 1, 2, 3, and 5 seconds. So displacement automatically means what formula am I using? I love it. All three of you yawning at the exact same time, not looking at each other. I'm so glad I can be entertaining for you guys. No. Displacement is the original. Ouch, this is like cutthroat rules. You make one mistake and name calling happens. Displacement means original formula. So at t equals 0, what is your y value? Are you sure this time? Okay. At t equals 1, what's your y value? Are you guys even here for the math? Probably not. What is it? Can you do it in your head? Do you substitute 1 in there? 4. At t equals 2. Right at 0. I thought somebody said. At t equals 3. Y equals? There. And then the last one was when t equals 5, y is? It is 12. Proud of you. Proud of you guys. Anybody want to hedge a bet with t when t equals 4 is? Okay. So hopefully you're noticing the symmetry of the parabola. Yes? No? Possibly. All right. So that was part A. That was pretty easy. Part B. What's the average velocity? Looking down my page. What's the average velocity after 3 seconds? So you know what? So the coordinate pairs you're going to use are 0 and 12. And what's my other one? After 3 seconds. So you're going to find the average velocity at 3 seconds or after 3 seconds. You need that average velocity for the first 3. So the next one I'm going to choose, my next point is that. Can you find average velocity? I have faith in you. So velocity is -4 meters per second. What the heck does -4 mean? What does -4 mean? It means the other way. I love that we don't know what. If it's negative, we would assume it's moving left. We would assume it's moving left like a number line. That's where your negatives are. You would assume that it's moving left. Does speed have direction? No. But velocity does. See, you've done physics. Good. I'm going to you off the island. What's the average velocity after 3 seconds? So you're looking for that period of time. You're looking for the average velocity for the, I would interpret that as 0 to 3 seconds. That's the way I would interpret it. You could argue, but after 3 seconds, how are you going to indicate? Because after 3 is an infinite possibility. You picked 5, because that was the dozen that we have. But what about at 27 seconds? Or 322? Right? So when it's written like that, you assume that it means between start and 3. Okay? All right, what's happening next? What does it want? What's the question want? C says, what's the instantaneous velocity when t is equal to 5 seconds? So velocity, average velocity is like over a section of time. Instantaneous velocity is at that exact. So if you want to do the hard way to limits, have at it. I'm going to do it the easy way with what? Derivative, my first derivative. So I'm finding it when t is equal to 5. My equation that I write here is, so my equation is y equals 2t squared minus 10t plus 12. So my derivative is going to be 4t minus 10. So y equals 4. Oops, that's supposed to be times 5 minus 10. So y is equal to 10 meters per second. And constant, so which direction am I going? Right. Or up. Whatever you want, Kevin. You do you. So D comes after C. D says, when is the velocity 0? At what time is the instantaneous velocity 0? Yeah. Oh, centimeters per second. Sorry, I was on the last one. Look at this. I can fix it. It's like it never happened, except I'm recording it, and then everybody can see that I think that's. But it's okay. Instantaneous velocity 0. So 0 equals 4t minus 10. And equals 4t. T is equal to 5 over 2 seconds. So at 2.5 seconds, you're going to have instantaneous velocity. When is velocity negative and when is it positive? You can graph it if you want to. I don't. I'm going to use a number line. So there's some critical values on here. What's one critical value? I'll give you a hint, I just found it. Right? So I'm using a number line, and it's like the t-axis or the x-axis. So I know that velocity is 0 at 2.5. That's the critical value. So now I'm trying to figure out which one's positive, which one's negative. What's another critical value? It's in the question. It's in the restriction in your question. So as far as I see this, I have three sections. I have the section between 0 and 2.5, and I have the section beyond 2.5. Okay? So you need some critical values to put on this before you can start measuring. So all I'm going to do now is pick values in between in my two sections here and figure out what the heck's going on. So pick a value between 0 and 2.5. 1. Crazy kids. So if t is 1, now I'm looking for velocity. So am I putting it into the original equation or the first derivative? First derivative. So if t equals 1, y prime equals -6. So what do you know about this section here? Negative. You could assume that this is positive, but assuming things in math is never a solid plan. It'll take you 2 seconds to test it. So pick a value greater than 2.5. 100. All right. So t equals 100. What's y prime equal to? 390. All right. So positive or negative? All right, so we can make a statement. We have to make a statement about time. So what do we know? Do you want to use intervals or set? Intervals is the next one that you always use, or do you want to use set for fancy brackets? Both. You want to They're not right. Okay, so when you have a negative velocity, t has to be, should it be 0? Yes, because 0 is included because it has a negative velocity at 0. Right? So it's an inclusive, and it goes to 2.5. Would I include 2.5? No. Yeah, because it's 0, so we not include it. You're smart. And positive velocity is 2.5 included. This is the big debate. Is 0 positive? I love it. It has been classified. I wouldn't because it's 0, so those would be my brackets. If you put inclusive, I'd probably still give it a mark because it is pretty normal to include 0 with a positive set. It's neutral, so we didn't include it anyway. But oftentimes we will include it with a positive set. If you want it to belong to something. How do you write 2, the number 2? Do you write a plus sign in front of it? No, it's an implied thing, right? So someone could assume that because 0 doesn't have anything in front of it, it could be assumed that it's positive. No, negative. 0 is never negative. It's always an implied positive, but if you said to me, I don't agree with that, then I'm proud of you for having an opinion. Okay? Where am I? Come on, letter F. This is like the never-ending question. Letter F. When does the particle reverse directions? You already solved this answer. 2.5. So this is yours, Kevin. You're not including it in either. It's the point of reversal. You're going negative, you hit 0, and then you switch to a positive velocity. What is the displacement when the velocity is 0? So you take your time of 2.5 seconds and you sub it into the original equation. Because again, I'm using displacement equation. So that's a long question, but it's not an unreasonable one. None of the math was hard in it. You guys have all the skills to answer that question. Oh, there is a lot of space there. That's weird. That's not what I had planned. Acceleration is defined as the change in velocity over the change in time. What do we know acceleration to be? What level of derivative? Second. Okay, if I reach the velocity of 100 kilometers an hour in 10 seconds, calculate the average acceleration. So, change in v over the change in t. My first coordinate pair, what would be my first coordinate pair in regards to velocity and time? 0 and 0. What's my second coordinate pair? Does that make sense? Your car starts, it's very excited. Yeah, super pumped to be here. So I'm going to have 100 minus 0 over 10 minus 0. So we're going to have 100 divided by 10. The answer is 10, right? It's not. Right. The units are different. So your answer is not 10 here. This is kilometers per hour, and this is in seconds. So we're going to do some units. We're going to do some unit changes. Acceleration is usually done in meters per second squared. Right? You remember this from physics? I do stuff like this. So let's change it. So if I need to change 100 kilometers into meters, how many meters is that? If I want to change an hour into seconds, how many seconds is in an hour? 3,600. And that's all divided by 10 seconds. That's a lot of math. It's a lot of math. So what do we get? So let's just go 2.8 for funsies. Is the right answer. Did you divide by 10? No? Okay, and this should be 1 on the bottom, because that's per second. No, that's not right. It's 10, so let's move a decimal place. Oh, I don't. It's 100 kilometers. 100 kilometers isn't 10,000. What is it? No, it's not. It's 100,000. There's 100,000. Oh, so many mistakes. I switch a zero in there. You just ignore my mistakes. I love it. Okay. Okay, do you need to do the math for you? You're good? Ramona's having an emotional epiphany, maybe? You're multiplying by the reciprocal, right? No. You just think it would be opposite. Right? So kilometers on top, 1,000 kilometers times by 36 times by 10 seconds times per second. Okay. Okay. All of this instantaneous acceleration. Anybody want to know what it is? Your second derivative. Average, we actually have to calculate it exactly like velocity. Instantaneous, we're going to do the second level derivative. So let's look at our last example, which has only 5 parts to it. Easy peasy. All right. So it says the position function. Position function. Hi. Guys, we got 15 minutes. Just if I can have your attention for like 5 more minutes, then we'll be good. After that, have our position function is a displacement function. Just another name for it. So that's your original function. Determine the velocity function at time, at t. So what does that really mean? I'm just rewriting the equation for velocity. And so we know velocity is my first level derivative. So my equation is s equals 2t cubed minus 4t squared minus 12t plus 24. My velocity function is going to be 6t squared minus 8t minus 12. Sorry, it shouldn't be b prime. It should be either s prime or b. You can use either of those. Okay, so for part B, determine the equation of the acceleration. So really, we're either finding b prime or we're finding the second derivative of your displacement function, or we can call that your acceleration. I don't care what letter you use, but you know what all that means. Great. So let's call it A. So A is going to be 12t minus 8. Oh, thank goodness for derivative rules. We don't have to do that the long way with limits. Somebody spent time figuring that out, though. Just FYI. Before your social media, you look time to have fun. Determine the acceleration at t equals 2 seconds. If I've given you just 1 point, if I said find the acceleration at this moment, you can assume I'm talking about instantaneous velocity. 12 times 2 minus t is equal to 16 left. I'm nervous. That one there. Okay, part D, determine the time when acceleration is 0. Easy peasy. Guys, physics, super easy. I don't know why you guys don't love it. Good times. Okay, he takes you, like when you get excited about things as teachers, we just want to share our excitement, our love of this stuff. You guys are like, stop sharing. You're not supposed to say seconds, but it's not going. That was, I don't think about it. Determine when the velocity changes from increasing to decreasing or decreasing to increasing. What do I need? I need the number line. I need the critical value of 2/3, so 0.6 repeating. What's my other critical value? 0. Your restriction carries down through your derivative levels. 2/3 seconds. Well, I can't read that. Perfect. It's a D or an S. Okay, maybe, possibly. All right, what value are you going to pick between 0 and 0.6 repeating? 0.5 sounds great. So what's our acceleration when time is 0.5? -2. So this is my negative section. What value am I going to pick when t is greater than 0.6 repeating? Perfect. T equals 1. I like that. Yeah. Acceleration is going to be what? 4. Brilliant. So this is my positive section. Oh, yes, I was doing acceleration. Okay, so what do we need to do? We need to erase this whole thing. What? I drew a perfect number line and everything. All that hard work, and I screwed you over by making you erase it. It's because nobody's paying attention to me today, and I'm acting out. So what's the critical point that I need? I mean, what B is 0. So I think we figured that out, didn't we? Okay. You just factor what you got. What can I can take a 2 row. So 3t squared minus 4t minus 6. 18 factors of 18. Well, we use the quadratic formula. Or not? Don't you have an app on your phone? I know I do. Well, what are the values? What are the factors of 18, negative 18 that add to a negative 4? I don't know any. I don't think there's any next ones. 6 and 4, yeah. The unknown factor pairs. It's okay. I'm walking over to get my phone. Like I don't want to do the quadratic formula. I just have Thanks. No, I just have an equation solver. And it's just a basic one, it doesn't show me anything now. Who am I showing my work to? Like, am I like, damn it. I wish somebody would have told me that sooner. Okay, so I said about the restrictions, follow all the way through. So this one gets rejected and gets replaced with what? What's your restriction? 0. Well, I guess it's not at 0 at that point. And then we have 2.23 is our other one. 0. Okay, so what is our value that we're going to pick between 0 and 2.23? Thank you. So what's the velocity at 1? 6 minus 8 is -2. -2 minus 12. So velocity is a -14. Yep. Oh, we could have picked 0. You told no because the other ones started at 0. Oh, no, you're right. Because this was the one that we found for 2. In the acceleration, we only had one answer. It was 2/3. So we could have picked 0. You were right. Right, yeah, you're totally right. T equals 3. 54 minus 24, 30, 30 minus 12, 18. Woo! All right, so let's make our statements over here. So negative velocity. Negative velocity is going to be from, are we including 0? No, didn't we just have this discussion? We did in the positive. Are you sure? I don't think I did that. At 0, it is a negative velocity. Just because you wrote it down like that doesn't mean I did. You probably heard it. Okay. All right. But yes, negative velocity is at 0. It is a negative velocity, and that is 2.23. I can't write my 3. I hope you guys can. Round bracket, and then positive velocity. Okay, guys, you're just gonna have to listen because this isn't working. Oh, here we go. I didn't want you to have to actually listen. 2.23 to positive infinity, not inclusive on the 2.23.